Hi to everyone. Okay, in this video we're going to cover module 5. We're going to look into module 5, which is our new module, but this video is specifically only for one subtopic. Later on you're going to see how many subtopic that will be covered for module 5, and this is only 5.1. Okay, what we're going to look before we're going deeper, we're going to see what is the objective and what we're going to learn throughout our module 5. Sorry, I forgot to use the pen. Okay, we're going to look into Central Processing Unit or CPU. Last time, in our previous module, we already looked so many things under CPU. You already know some basis informations about CPU, and of course, you have three main elements. What that's three main elements in for CPU? Inside your CPU, there supposed to be the ALU, arithmetic logic units. Another one is your register. And what is the register? What is another one? So another one is your control units, your CU. So this is all basically your three elements inside your CPU. But are we going to learn in all this one, ALU, register or control unit? I guess we're going to look into several parts. We're going to divide it, like we're going to look into the architecture, the process, and so on. So the objective is to learn the component commands to every CPU. Much more onto these common components. Be able to explain how each components in CPU contribute to instruction cycle. What ALU will do, contribute. What ALU contribute to your CPU? What register contribute to CPU? Is it another extra component? Are there? So later on you will see it. And to understand the concept of pipeline in CPU educations, this term we're going to look into what subject? HPPC, high performance data processing, HPDP, and high performance computing, high performance processing computing, something like that. Okay, that subjects, if you take, then normally you're going to look into these pipelining terms. Okay, be able to understand the micro operation basis for the design and implementations of the control units. So this is these four objectives, what we're going to cover in our module 5. Now we're going to look into what subtopic inside our module 5. First subtopic is 5.1, is processor organization. So in this video we're going to cover 5.1 only. So if you're going, if you are looking 5.3, 5.4, or 5.2, it is not going to cover in this video, and maybe you can look into different video. Okay, then we're going to learn register organizations, instruction cycles, instruction pipeline, control unit operations, microprogram control, and lastly, of course, we're going to summarize all what we have learned throughout our module 5. Okay, now we're going to look into what is the overview under our processor organizations. What is organizations? What do you think that you're going to cover and what you're going to learn in our 5.1 subtopic? There are basically several elements that you need to consider which is to understand the organizations of your processor. Of course, because you are learning your CPU, you need to have to able to put several considerations to the requirement placed on your processor. So there are several considerations that you might need. So the things that it must do. So there are several, which is 5 altogether, which is first fetch instructions, second interpret instructions, fetch data, process data, and lastly the write data. So these 5 things you need and must do to consider the requirements placed on your processor. So what is fetch instructions? Normally you look into this normally because your code are always read from your instruction givens, and mostly it is from your memory. And your memory, of course, there are sometimes you have your register, you have your caches, and your main memory. Interprets instructions. The instructions is decoded to determine what action is required, and then the executions of an instructions may require reading data from memory or input-output module, which is under the fetch data. I guess this all you already look at some of it, only that in terms of theory. Now you look into deeper on that. The executions of instructions may require performing some arithmetic or logical operations on data. This is your process data. And lastly, your write data, which is the result of execution, may require writing data to memory or input-output module. So depend on how you write your instructions. To do these things, the processor need a small internal memory to store some data and instruction temporarily. So this one you already look, which is we learn on your stack, you learn on your register. So there are several of temporary place that you can put. Last time you learn on stack, which is you store whatever come in your instructions, while an instructions is begin executes. So let's say you have I forgot last time, move to it 0, 0, 0. Ya Allah. Okay. So you move to inside, you move it inside. Oh, sorry. We pick this one first. We move our 0, 0, and then 0, 8 at 0, and then 0, 2. Okay. So we put into our stack. Let's say this is 0, 0. Yeah, sorry ya. Okay, 0, 0, 2. So yeah, okay. Let's say this is your address in your register. So you already learned all of this, how you are storing into your temporary memory. So let's say what ALU do, what register do, what controller need you to contribute to this thing. So what is the tugas? What is the main task of all of this? So there are two basically. You're going to look into data parts and control unit. So before we go that deeper, we're going to look into what is basically happen inside our CPU with the system bus. So you can see they are connection to each other. This one is just under control unit. You can also see there are a data bus, and another one is your address bus. All are connected to your CPU, and inside your CPU you have three main elements, which is your ALU, register, and control unit. So ALU, what is the main task, which is thus the actual computations or processing of data. While your register, minimal internal memory, consisting of a set of storage locations. This is the task of your register, which is minimal internal memory, consisting of set of storage location. And for your control units, it's control the movement of data and instructions into or out of the processor and control the operations of ALU. So this control unit need to control this ALU, and ALU are processing the data. It's going to process the data, and this control unit will instruct the movement, the data that are coming out from the ALU, whether it is going to be in, out, and etc. So all the movement of the data are being controlled by the control unit. After this, you're going to see, okay, because you have data parts and control unit. The computer CPU fetches, decodes, and also executes program instructions. So there are two principal parts of CPU: data parts and control unit. So which one is data parts? Which one is control unit? Is it control unit? Is control unit? So how about the data parts? Data parts is look like a movement, right? Path. But let's take a look. Can you think what is the answer before we move? Okay, now I give you the answer. Sorry. Okay. Data parts consists of an ALU and storage unit, which is your register. Means that your data parts is having ALU and also your register. Why? Isn't control units is the one that control your movement of your data? But what is the meaning of part here? Okay, let's take a look. That are interconnected by data bus. You can see over here, you have the bus. This one is your register. This is your ALU. You can see this is your ALU, and this is your control unit. So now your data parts are being covered by the red box over here, which is your ALU and also your register. And you can see over here, it's interconnected by a data bus. You can see internal CPU bus. It's connected to register and also your ALU. Okay, saya tak nak hodoh-hodoh sangat. Okay, that is also connected to main memory. It also connected to your main memory. So you can see under your ALU, you have the status plug, shifter, complementer, arithmetic, and Boolean logic. This one is like more to your mathematical algorithms. And you can see all of this are interconnected to each other between ALU and also register using your data bus. And this data, this bus will also connected to your main memory. Okay. Next, you can see the red color now is your control unit. The control unit provides signal to tell data path. So these control units will going to provide your data paths. You're going to give a signal to the data paths. To siapa? To ALU and also your register, memory, and input-output device. What to do according to the instructions of the program. So control units meant give the main task. This is the one that control everything. Control unit will control not only the data parts which is consists of your ALU and also your register, but also it's going to provide the signal to your memory and also input output device. What to do? What to do according to the instructions of the program. So this is the two main principal part of your CPU, data parts and also control unit. Now you already know. Under your internal CPU bus, you can see over here. Now we're going to look into this part. Because you already know about your ALU, you already know about your register, but maybe you're going to go deeper later on. In internal CPU, your bus, you didn't learn yet, isn't it? So let's take a look into what is internal CPU bus. The registers are interconnected and connected with main memory through your command data bus. This one is you already know, right? Each device on the bus is identified by unique number that is set on the control line whenever that device is required to carry out an operations. Wow. Means that you have unique numbers inside your internal CPU bus, because it's need to set each device on the bus is identified as with the unique numbers that is set on the control line whenever the device is required to carry out an operation. Let's say you have the comparator. So you have a unique number. Let's say I just put it 1 to 1. You have another one is subtractor, counter 1 to 2, 1 0 1. Let's say. So So whenever you want to call out your comparator, your counter, your comparator, your subtractor, you need to use the unique number. So separate connections are also provided between the accumulator and also memory buffer register, and another one, the ALU, the accumulator and memory buffer register. So you need to know not only interconnected start available, but a spread connections also provided in your internal CPU bus, which is between this and this. This permit data transfer between this device without use the main data bus. So this is the hints for these separate connections. So if let's say there is a question asking you what is separate connections means. So the spread connections did and do the data transfer between device without use the main data bus. So that is the task. Next is under external bus. So you can see you have internal, you need to have also external. Sama lah, we're going to have boy and girl, in and out. Same goes also if we have internal, then we can also have external. A bus is a set of wires that simultaneously convey a single bit along each line. So what is it? External bus. About external bus, a bus is a set of wires. So whether it is external bus or internal bus, we need to know the basic about bus first. A bus is a set of wires that simultaneously convey a single speed along each line. So maybe you have thousands of wires, which is you use it simultaneously convey a single bit along each line. So bus line, you have data line, control line, and address line. This is the three main categories under your bus. See, you can see over here, this is your CPU. Of course, you have your ALU. I guess this one is your CU, and this is your register. Your CPU are connected to your main memory as mentioned previously in your previous slide throughout your bus system, of course. But bus have several types, which is data line, control line, and addresses line. Address bus, you can see it's going out. This is the address bus. But for data bus and also control bus, it is interconnected to each other. You can have the correlation between each other, between CPU and also your main memory. Same goes to your data bus. But for address bus, it's going out only to directly go to your main memory. Going to push in, push in, push in. Wait, what time now? Okay. Okay, now you can see you have the input-output subsystem. You connect also with each other. You can see your data bus interconnected to each other, and same goes to your control unit. But address bus is only one way to your input-output device or your input-output subsystem. So what is basically data line, control line, and lastly your address line? And the control line convey bit from one device to another. I delete first. Okay. So data line is convey bits from one device to another. The number of line, wow, 32. I guess this one is, it is not thousand, million. 3,264,128. Give the width of the data bus. Example, which is 32 bits, instruction length is 64 bits. This means the processor must access the memory module twice during each instruction cycle, because you have the bits is 32, but when you have the instructions length it is 64. It is means that you need to have 2 times. Okay, now next is under control line. Determine the directions of data flow and when each device can access the bus. Use control signal, timing signal, command signal, which is to the memory write, memory read, bus request, and also bus grant. And lastly, under your address line, determine the locations of the source or destinations of the data. So this one only one way. Example, want to read data in memory. Put address on this bus, go to the memory, get the content, and put it on the data bus. So this is the examples under your address line. So this is all about your 5.1, which is on your organizations of your processor. Is as I mentioned previously, it is only a small part before you're going to go deeper in your register organization, instruction cycles, instruction pipeline, control unit operations, and lastly Microsoft program control. So thank you for your watching, because we already finished this 5.1. Later on, I'm going to cover 5.1, 5.2. We're going to look into your register organizations, what is the overview, user, visible register, control, and status register in our next video. So this is just okay. So thank you for your watching, and please stay safe. Bye bye.